Hello, everyone. Thanks for joining me again. Let's go ahead and find out what is the nth test for divergence of a series. So have a series, we know it's going to diverge if you take the limit of your sequence an, which is your formula right here. You take the limit of that portion, and if the limit fails to exist, what that means is that the limit does not exist. Or you can get a statement like infinity or negative infinity. Then that series will diverge. Or if you get any value that's different from zero, so if the limit is not zero, it's any real number but zero, then that series will diverge. So for instance, you can write this as, if you take the limit as n gets larger of your sequence an, if this is not zero, then we can say that the series from n starting from 1 to infinity of an is going to diverge. So this is a very powerful statement, but we also have to make sure that it does not tell us anything about convergence. If the limit, so here's something to be mindful of. If you take the limit as n gets larger of an, if this is zero, if it's zero, then we don't know anything about that series. So this means that this test is inconclusive, meaning you cannot draw a conclusion from the test. So we can say this is inconclusive. That means you have to apply different tests to figure out if it's going to converge or diverge. So be very careful. We have to make sure the limit either doesn't exist or it's different from zero. Let me show you some example and see how you feel. Let's take a look at this series. We're looking at the sum from n starting from 1 to infinity of negative 1 to the power n plus 1 times n. Let's write out some of the terms. So this is your an. So if I let n equals 1, I have negative 1 to the 1 plus 1, that's 2 times 1. Plus, if I let n equals 2, I have negative 1 to the third power times 2. Plus, if I let n equals 3, I have negative 1 to the fourth power times 3. Plus, let's go write one more term so you start seeing what's happening to this series. If I let n equals, so 1, 2, 3, 4, then you'll have negative 1 to the fifth power times 4, and so on. So if you clear out the negative, this series is negative 1 squared, so that's 1, plus negative 1 cubed, that's negative 1, times 2, that's negative 2. And then we have plus negative 1, 2, that's positive 3. And then negative 4, positive, and so forth. So you start to see that this series, it's keep on, you have positive 1 and then negative 1 times 2, and then positive 3 and then negative 1 times 4, and so forth. So you start to see where this series is going. You have 1, negative 2, and then 3, and then negative 4, and so forth. So if you're adding them up, we take the limit as n gets larger of our an, which is negative 1 to the n plus 1 times n. This limit, it seems to does not exist. So it's not equal to 0, which means that our series n starting from 1 to infinity of negative 1 to the n plus 1 times n is going to diverge by the nth term divergence test. So by this test, because the limit failed to exist, we can conclude the series will diverge. Let's go ahead and apply the nth divergence test for this particular series as well. So this is our an. So if you want to write us all the terms, feel free to do that. I will, and then I'll take the limit. So before I take the limit, I'm going to write out some of the terms. So I'm familiar with how the series looks like. So this is going to be, if n equals 0, you have e to the 0th power. Plus, if n equals 1, you have e to the negative 2. Plus, if n equals 2, you have e to the negative 4. Plus, if n equals 3, you have e to the negative 6. And you got the idea. So it looks like, so the first term is 1. The second term, if I made the exponent positive, this is 1 over e to the second power. the third one 1 over e to the fourth, and the next one 1 over e to the sixth. So you start to see where this is headed, but let's take the limit. So we're familiar with how the terms look like, but we want to see what happens as n gets larger of this formula, e to the negative 2n. So rewrite this. This is the limit as n approaches infinity of 1 over e to the 2n. So I'm going to write it like this. Now, as n gets larger, this is going to be very large. And 1 over a very large number, we know that's going to be 0. So this limit is 0. Now, oops, our test for divergence fails. So we don't know what's really going to happen to this series. So test for divergence fails. So our test is inconclusive here, so you'll have to apply a different test. Now, if you remember, this does look like one of the series I have introduced to you before. This is a geometric series. If you are wondering how to work with something like this, feel free to watch the video that I'll leave in the description box. You can call this is a geo series. Apply the geometric series test, and I believe this will converge because let me show you a little bit of idea of how to deal with this. So if you were to rewrite this in that particular form we did before in another video, you can write it like this. You have the sum starting from n equals 0 to infinity of 1 over e to the 2n, which can be written as the sum starting from n equals 0 to infinity of 1 over e to the 2 to the n. Now that's a geometric series form. So a is 1, this is your r, and this r is within the restricted boundary of negative 1 to 1, so it's going to converge. So this is going to converge by geometric series test. But by the divergent test, we don't really know what's going to happen. We got the limit to be 0, so that test fails. Now you went to the next test and you identify that this is a geometric series, write it out, find what it converges to. So let's try another example. Here is another series. We're going to apply the test for divergence, see if this is going to diverge or not. So I'm going to take the limit of my formula an. This is our an. But before I do that, I'm going to write down just a few terms of this series. So if n equals 1, you'll have ln of 1 over 3, plus if n equals 2, you have ln of 1 over 3 squared, plus the next term ln of when n is 3, you have 1 over 3 cubed, and so forth. So I got an idea how the terms look like. Now let me take the limit. So the limit as n gets larger of ln of 1 over 3 to the n. Since ln is continuous as we get to infinity, I'm going to push the ln outside the limit. So you have the limit of n approaching infinity of 1 over 3 to the n. I have ln of all of that. Now, well, what's happening here as n gets larger? That looks like it becomes very small because 3 to the n power is very large. 1 over that is going to be very small. But since we cannot evaluate ln at 0, I'm going to write this as ln of 0 from the right. So it's a positive but small number. Now, ln of 0 from the right, well, that's going to be negative infinity. Because if you look at the graph of ln, it looks like this. So here's the graph of ln. And as you get closer to 0 from the right, you're heading this way. So it's going to negative infinity. Great. So the limit, we got negative infinity, which is not 0. That is wonderful. So what does that tell us about this series? It's going to diverge by the nth-Divergent test. So we can say that, therefore, by the nth-term divergence test, we can conclude that our sum, which is this one right here, starting from n equals 1 to infinity of ln of 1 over 3 to the n diverges. Since the limit is not 0, it's negative infinity, we can conclude it's going to diverge. All right, so here's our one last example. We want to know if this will diverge by applying the nth divergent test, or let's see what happens. So I'm going to go ahead and, so this is your an. So let's take the limit, applying the nth term divergent test. As n gets larger, we're taking the limit of n factorial over 1000 to the nth power. So let's write out some of the terms, see what's going on here. So I take the limit as n gets larger, n factorial, that's n times n minus 1 times n minus 2 times all the way, just keep on going. And then you'll have 1000 times less than that, so that's 999 times, just keep on going. And then the last three terms will be 3 times 2 times 1. So that's what n factorial is. You write out all the products starting from n and going down all the way to 1. So the denominator, we just have 1000 n times. So you have 1000 times 1000 times 1000 times, and keep on going, then you have 1000 times, but you got the idea. So just gonna fill out up to the last term, so keep on going, 1000, 1000, 1000. All right, now let's group them this way so we can see what happens to the limit. So I'm gonna group them this way. So this is one term, this is the next, and keep on going, start grouping them this way to see what's going on with the limit. So as n gets larger, well, what happens to this one? So you have a very large number over 1000. Well, it's gonna go to infinity. Same thing with this one. These are all gonna go to infinity because they keep on growing, because the numerator is greater than the denominator. It's always 1000. But here, this is gonna be a constant. So you have 1. And then here, this is also gonna be a constant. All of these are just going to be a constant. A finite value, very small finite value. So in other words, this limit is actually approaching positive infinity, which is not 0. So therefore, by the nth divergent test, the series will diverge. So we can say that, therefore, by the nth term divergence test, this sum starting from n equals 0 to infinity of n factorial over 1000 to the n power going to diverge. All right, so I hope this helps you with the nth term divergent tests.